Okay, guys, let's get started. Thank you for coming to the Quantopian tutorial series webinar. This is the third video, the third webinar that we've done so far. The first two are posted in the community, and in those we covered the basics of the backtester as well as using fetcher in your algorithms. In this webinar, what we're going to be covering is the basics of how to use fundamentals and also a couple algorithms. One algorithm that I personally wrote, which is a multi-factor fundamental query, and two others that were created by users in the Quantopian community, and they were actually two out of the seven algorithms that won our fundamental contest. And you'll get details on that shortly. But before I begin, I just wanted to mention that the Quantopian Open February deadlines have passed, but we've just opened our March submission, so you can submit your algorithm to the Quantopian Open until March 2nd. So feel free to start working on that. And also, we have a conference coming up in New York City. It's called QuantCon. We have a lot of amazing speakers. It's going to be on March 14th, 2015. A few of the speakers that we have is Ernie Chan. You might have read his books. They're really big in the quant finance community. We have Matt, who is head of product of IEX, and also Mebane Faber, and a ton of other speakers as well. So the early bird pricing right now is about, I believe, $249. So get on that quick before the prices rise. Um, and that's it. So let's start with this webinar series. So I mentioned before that we're going to be covering the basics of fundamentals. If you guys don't know, recently about a month ago, we released about 13 years of historical fundamental data. And basically, if you don't know what that is, it's basically all like everything you'll find on a balance sheet, the company headquarters, what sector the stock ticker belongs to, what its IPO date was. It's a ton of data, and we're doing it in collaboration with Morningstar. Um, so basically, if you need Apple's, quarter three earnings in 2006, you can query for that. If you need Microsoft's company headquarters in 2008, we have that. If you need Netflix's IPO date, we also have that as well. And it's all point in time, which means that whenever the backtester is running, let's say it's January 1st, 2006, and you're querying for PE ratio, it's going to give you P ratio at January 1st in 2006. But we'll get into that in a little bit. Let's go over the basic structure of this webinar. First, I'm going to be introducing this new function called before trading start. Uh, if you guys don't know, up till now we've only covered initialize and handle data, but there's this new function that we call before trading starts, which is going to contain our query for fundamental data, and then I'm going to cover how you actually go about getting different pieces like PE ratio, getting pieces like IPO date, getting pieces like company headquarters. Next, I'm going to go over the amount of securities that you can obtain at any given time, which is the universe of stocks, which I covered extensively in the second tutorial. And finally, after that, we're going to go over three different algorithms, seeing how much time that we have when we get there. The first is the Pirotrovsky score, which we wrote over here at Quantopian. Next, we have growth ranking for healthy stocks by Naoki. Finally, we have identifying uptrending volatile small caps by Richard. Um, and those are the three structures. And this documentation and guide is going to be available to you guys after. I'm going to post it up in the community so you'll have everything that you need. And that's it. I'm going to get started now. First things first, let's go over basic concepts. Before, I mentioned that Up till now, you guys have probably only seen initialize and handle data, but now with the introduction of fundamentals, we have this thing called before trading start. Before trading start is basically another function that gets called after initialize, but before the start of the trading day. And then here you're going to have this thing called get fundamentals. Now, before trading start takes in context as your parameter, and you can kind of do other things instead of, I mean, you can do other things instead of just doing fundamental stuff. So if you wanted to update your number of securities, like update any variables in context before trading starts, you could go context dot number of stocks to hold equals 10, and you can increment this each and every day, and it would only do it once per day. And that's kind of it. I know that it's another function that you have to use on top of initialize and handle data, but it's a pretty simple concept. Um, and this is the only place where you can have your query for fundamental data and this thing called update universe, which I'm going to cover shortly. So querying for fundamental data, really you only needed to know two different functions. One is called get fundamentals. So let's just go over it step by step. Get fundamentals, which you call here, and it's going to, hold on, it's going to autocomplete with all of these different things. So get fundamentals is just like kind of this umbrella function that contains four different parts that you can use. The first is query over here. The second is filter. The third is order by. And finally, we have limit. Now, each of these different functions serve a very specific task, and it revolves around this Python library called SQL Alchemy. And if you guys have used SQL Alchemy before, it's just um, a very easy kind of interface tool for you to interact with the database. Now, in this case, we modified it to our standards so we can make um, the use of fundamentals a lot easier for you guys. So I'm going to go over the four different parts right now that you need in order to get a fundamental data set working in your algorithm. The first part that we're going to look at is this query over here. Query is where you're going to specify the exact uh, fundamental fields that you want to access later in your algorithm. So here I'm going to say, so here you're going to specify if I want the P ratio, you're going to see that this autocomplete box comes up, so you can just type what you want in, P ratio, and let's say I want earnings per share, EPS, and finally I want, I don't know, IPO date. So when you specify these things in query, what actually happens is that this fundamentals, so get fundamentals right here, returns a data frame, a pandas data frame with the security symbol as the column name and these different fields here as the index. So if you think about a data frame as an Excel sheet, so if you think about a data frame as an Excel sheet, I don't know if I have it here. Okay, I'm gonna open up sheets. You're gonna have, this is what get fundamentals is going to return. We're gonna have Apple, we're gonna have Google, We're going to have P ratio, EPS, IPO date. So this right here is what you're going to be working with. And so if you wanted to get Apple's P ratio, you would do something like data over here and handle data of symbol Apple. No, you would actually do, so I would do context.fundamentals equals fundamentals. Then you would do something like those of symbol Apple, and you simply do P ratio, and that would give you the P ratio for Apple. It's very, very simple. One thing to note is that you have to set fundamentals to a context attribute, which you can do right here. So context.fundamentals. So to summarize that really quickly, query is where you actually specify the exact fundamental fields that you want to access later in your handle data. So you can imagine yourself doing a lot of cool things with this, like weighting the average P ratio to find the top 10 technology stocks with the highest P ratio and shorting those. Something like that. It's basically anything that you want to do with a balance sheet field, you can do using this. So that's query. Next, we have filter. Now, filter is here to help you narrow down uh, the securities that you want to be looking at. So right now, when you do get fundamentals query and you didn't have filter here, if you just did not have that there, you would be looking at basically all the securities in the tradable US market. And I'm going to go over this later, but you have a restriction on the number of securities that you can be looking at any given time. So if you were to just do this without limit, you would basically uh, be your algorithm wouldn't run because you have too many securities. So even with this here, you're kind of throwing like this random ballpark estimate at like the 8,000 9,000 securities that you can trade on. So what filter allows you to do is to say, okay, I have all of these fundamental fields, but I want to look at only the stocks where P ratio is greater than 5, or where P ratio is less than 10. So this allows you to narrow down your universe of securities, so you can get a better and more targeted look at the securities that you want to be trading on. And you can basically do this for any fundamental field. You're not just limited to the ones you have in query. So notice in query that I have P ratio, EPS, and IPO date. But let's say I wanted to get all the stocks with cash flows that are positive. You could also filter for that. You're not limited to just what's there in query. And this is just like a really helpful way to just narrow down what you're going to be working with. But yeah, that's kind of it. Actually, it's actually a very simple concept, and that's filter. So let's say, okay, so now we have P ratio that's greater than 5, P ratio that's less than 10, and free cash flows are greater than 0. But what if I wanted to just look at the stocks with the greatest market cap? You can do that by using this order by method, where you can specify market cap, order by market cap descending, which basically says, give me all the securities with the biggest market cap. So if you were to leave this out, it will give you all the securities with the smallest market cap. And it's going to order your list of stocks by that way. pretty simple. It's basic sorting. And finally, you have this dot limit method, which says, give me after this order by method or whatever. If this order by is not there, whatever is left after your last filter method, give me the first 100 stocks with the biggest market cap in this instance because I'm ordering by market cap over here. So this limit by helps you like really narrow down your universe dependent on how many securities that you currently have. So the maximum number that you can be working with at any given time is 200, but here you can set it to 100. Or you can set a variable in initialize that says context.limit equals 50 and pass that in here. Context.limit. And that's kind of it. It's actually kind of simple. So to summarize what we just gone over, we have a query. So the 4 parts of working with fundamentals is that you have query, filter, you have order by, and limit. And to go over that, it's query is where you specify the exact fundamental fields that you want to be accessing later in your algorithm. Filter is where you're doing a more specific, kind of, I guess, best way to describe it is the name filter. You're filtering down your universe. Order by is letting you define. So let's say if you wanted to get the top 100 securities with the biggest market cap, order by lets you kind of sort what you've just sort the query, sort the data that you just got by query and filter, and limit by helps you complete that by saying, okay, I just sorted all of these stocks by market cap, give me the top 50 in this case. So once you have that, you're going to have a data frame that's now stored into context.fundamentals, which if we remember looks like this, where the stock is going to be the column name and the index is going to be the fundamental fields. And finally, if we want to update our universe of securities, so if you want pricing data for the securities that we just got from get fundamentals, you can simply do update universe context.fundamentals columns value. Yeah, values. Now this is just going to take all the securities in your column list and make that your daily universe. Now this happens once per day. And to reiterate, you have a maximum limit of about 200 securities at any given bar, especially with context.fundamentals, with get fundamentals, I mean. So if I do this right now, notice that my context.limit is set at 50. So my universe, my daily universe is going to consist of 50 securities. And that's kind of it. That's really the basics of how you use fundamentals. You can obviously do a lot more things here. And you're gonna see that as we go over a couple of different algorithms. But up till then, and by the way, we're gonna have like a question and answer section at the end of this webinar, if we have time, and if not, there's gonna be a thread posted on the forum, so you can always ask your questions there as well. So just hold tight, and I'll go over that. But yeah, that's really the basics of using fundamentals. And if let's say you wanted to access that data somewhere in your handle data, you would do something like for stock and data print context.fundamentals, which is what I got from get fundamentals over here, of stock of P ratio. And it's really that simple. And yeah, that covers the basic part, the introductory part of this webinar. We're gonna start going over different algorithms right now. So the 3 algorithms that we're going to be going over are the Pirotrovsky score, which was created by a professor at the University of Chicago. Next, we have Fundamental Growth Stocks by Naoki, which is which is more of a basic fundamental algorithm that is more of a pure fundamentals, and that it just uses fundamentals to narrow down its list of securities. And finally, we have Identifying Volatile Small Caps by Richard, which is more on the advanced side, where it combines like a linear regression and a volatility filter before moving on to make its buy and sell choices. So um, we're going to be going over that for the rest of this webinar, and finally, at the end, we'll have a section open for you to do some Q&A. So first, let's go over this Piotr. Actually, I'm going to go over Naoki's algorithm first, which is a bit simpler, and it's going to show you exactly what we just learned in in the introductory part of this webinar, and it's going to show you how some of our community members are using it in action. So this algorithm, what it's basically doing is that it's using Morningstar's uh, sector code and also the revenue growth in on the company's balance sheet to filter out for the biggest growth stocks, and it just buys them. Um, and you can see the performance here. It's done pretty well over the past since 2003 up till November in 2014, with like returns of about 230%. So um, let's walk through this fairly quickly. So there are a couple things that are going on here. First, we notice that he has this initialize section, which defines rebalance, which is going to be run every month. So he's rebalancing his portfolio at the start of the month at market open. I won't be going over that part, but you just know that rebalance just takes that into account. And so we go over to the before trading start function, which we saw before as I was explaining. Um, so here we're going to be going over the same process, exactly what we did before. We have this get fundamentals method, which has this query part, and in this query part, Naoki is looking for revenue growth and the Morningstar sector code. And after that, he's filtering by where market cap is greater than zero, where return on investor capital is greater than 10%. And that's just like a basic net just to get out the stocks where where growth might be high, but return on investor capital is low, and we don't want to really be looking at those. Finally, he has this shares outstanding does not equal none. I believe now you actually don't need this anymore, so you don't really have to bother with where fields do not equals none. Finally, he has this order by revenue growth descending. So what he's doing is he's looking for the companies with the biggest revenue growth, and he's taking the top 100. So to summarize, we're in this fundamental query. What we're doing is that we're looking at the entire universe of tradable stocks, which is about 8 or 9,000 in the U.S. market. We're finding the revenue growth and the Morningstar sector code of each security. We're taking all the stocks where market cap is greater than zero and return on investor capital is greater than 10%. Finally, we're taking all of that. And then after all of that filtering, we have whatever X amount of stocks, and we're going to looking through those stocks, find those with the highest revenue growth and take the top 100. And once we have this top 100, what Naoki does here is that he takes um, all the stocks that fundamental query has gotten, and he updates his universe with that list of securities. So what he does here, he does an iteration over the fundamental data frame that we got from here. But really, if you wanted to make this even simpler, you could also just do context.fundamental df equals fundamental df, and just take the columns of that and take the values. And finally, he records the amount of cash that he currently has in his portfolio, and also his total portfolio value as of that day. Now, this is going to do it daily because before trading starts runs before the market start each and every day. And finally, he has this rebalance function, which is very beautifully crafted, and it takes all the cash that he currently has in the portfolio, makes sure that he exits all the positions before starting any new ones. Finally, he creates weights for each stock, which is simply all the stocks that are currently in his universe, and equally weighting them. And he rebalances each stock to the weight that he just got from create weights. And before he does that, he also makes sure that he is not going to run into leverage, and that the stock is not currently thinly traded. These are just a number of simple checks that I'm not going to explain too in depth right now, but it's explained pretty heavily in the in the in the study guide that comes with this webinar. So check that out if you guys want a more in-depth explanation. Is it just basic trading cards that you should have whenever you're crafting any algorithm. So that's it for this one. It's really simple. If anything, this is kind of a very, very pure fundamental algorithm in that it looks exclusively at one fundamental factor that we have in our database, and it uses that to say, oh, I think the high growth companies are going to give me the most amount of return. And if we look at the returns that come from it seems pretty good. So give that a look. The link is going to be in the study guide and the community and the thread that I'm going to post up as well. So next we're going to go over another algorithm, which is based off the Pirotrovsky score, which was created by Joseph Pirotrovsky, a professor at the University of Chicago. He, I believe, was an accounting professor, and he theorized that the strength of a company's balance sheet is going to determine how it performs in the stock market. So basically, what he does is that he says, look at these nine different fundamental factors, and for every criteria that the stock meets, that security gets a point, and we should go long on the stocks with the highest amount of points. So basically, going through this list, if a stock has positive return on assets, a stock has higher return on assets in current year versus last year, they have no new shares issued this year, a point's going to be given for each of these different criteria. And if it has 8 or more, we're going to go long. And I believe you could also do like the inverse, which is if it has like less than 2 points, and go short. So in theory, and looking at the structure of the algorithm, it's actually very simple in that you're basically just listing off a bunch of different fundamental factors and buying stocks that fit this criteria. Now, the tricky part about this algorithm is that currently we don't actually offer a built-in way for you to access historical comparative fundamental data. And by that, I mean, if you're looking at fundamental data for January 2006, there's not an easy way for you to look at it in January 2005. Well, there is an easy way, and I'm going to show you guys that easy way right here, but there's no built-in way for you guys to do that. So that's going to be kind of tricky for you guys to wrap your head around. So definitely, if there's any questions, take them down and really just ask them when we have our Q&A section later. Um, so just like before, with this algorithm, we're going to have an initialize part, a before trading start part, a handle data, and a rebalance, just like a rebalance method, just like Naoki had. And also, we're going to have like these different little helper functions that are going to basically accumulate the different points for this, for each of these factors down here. Um, and it's going to assign a score for each stock with this get Pirotrovsky scores function, which returns a dictionary of each stock to its score. Um, and I'll go over that briefly after we go over before trading starts, but I cover that pretty extensively in the study guide. I just don't want to take up too much of your time right now. So if you look at the before trading start part, it's pretty, cookie cutter, exactly what we did before. We're just going to look at the different fundamental fields that we have up here. So things like return on assets, market cap, operating cash flow from continuing operating activities, so forth and so on. And actually, so something that I'm doing here is that I'm only looking at the 40 biggest securities in the market because um, you guys feel free to toy with this limit, but I just wanted to get something that ran fairly quickly and looked at stocks that we know there's going to be a lot of trading volume for. Just like before, I do context.fundamental.df equals fundamental df, and I update my universe with those values. Um, and that's like pretty simple. It's what we've seen, but that doesn't solve the problem of comparing this year's data versus last year's data. So if we look here, we have this field called cash flow from operation. No, sorry, the one above that. Um, Higher return on assets in the current year versus last year. So if you notice here, we are getting the return on assets, but the problem is we're only getting that point in time, which means we're only getting it for 2013 or 2013. We're not really getting it for like for like 2012 if you're looking at 2013's data. So actually, what I'm going to do instead is I'm going to create a Pandas panel, which is very similar to how a Pandas data frame works. But instead of a data frame, what I'm going to be doing is uh, creating a data structure that's exactly like how it's exactly how uh, data looks like in handle data. So if you guys have ever played with data in the debugger, um, if you guys have ever played with data in the debugger, it is a Pandas panel with one of the axes being um, the dates and one of the axes being the stocks and one of the axes being uh, the price. So if we looked here, we see that you have securities, the date time, and also the close price. So essentially, you can think of this panel looking like this: 1/1/2014, 1/1/2014, 1/1/2014, and if you repeat this down here, so this is what the structure of a panel is going to be looking like. I know that it's kind of confusing to get your head around because it's not it's more three-dimensional than it is two, but this is kind of the best way to look at it. So if I were to look for if I were to try to find like if I were to compare apples 2014 PE ratio versus 2013 PE ratio, what I'll be doing is Pandas Panel of Apple of 2014 to PE ratio versus Pandas Panel of Apple of 2013 P ratio. And this basically gives you like this point in time comparison, like this history comparison between the two values. I know that like the structure of it is kind of hard to understand, but if you can kind of understand that this is, querying for it is very simple. Actually making the data panel that you're going to be working is very, very simple, and it requires like almost no work on your part. And I'm going to show you guys how to do that right now. The first thing is that you need to create like this dictionary. And what this dictionary is going to do is it's going to be keyed on the date. So it's going to be keyed on the current date, which is, if you notice, I have it right here, context.fundamentalDict. The key is going to be the current datetime. And then you're going to assign the current day's fundamental query to that. So each and every day is going to be filled with the fundamental data that belonged for that exact date. So if you look at context.fundamentalDict now, you can see that it's keyed on the date, and its value is a data frame, which contains the security and the different kind of fundamental factors that we had before. And in order to convert that into a panel so that we can easily compare different date times from the current fundamental date to the historical fundamental date, you literally just need to call pandas, which I import up here, import pandas as PD. You literally just need to call pd.panel and put in your context.fundamentalDict. And it's going to create this amazing data structure that's exactly identical to what um, uh, data looks like. The data, okay, looks like I have to let it run for a little bit more. All right, so it only does it once every month, so need to let it run a little bit. Sorry guys, give me like 2 seconds. Okay, it's taking too long to do this. But anyways, if you ran the algorithm full on, it will give you basically something that looks exactly like what you have in handled data. And you can definitely, and I walked through it even more in depth in the study guide. So definitely take a look at that after the webinar is over. And in summary, so the algorithm queries for 9 different fundamental criteria factors. It assigns a point for each criteria that a security can meet. And finally, we create this like Pandas panel that you can kind of compare historical dates very easily. And how you exactly do that, I cover in the study guide, but just to show you very quickly, you basically go like, you basically take that pandas panel that I have, which is called fundamental data, and you you query it by the date. So right now, last year is set to some date time logic that I do up here, the same for the current date. So that's kind of the summary of this algorithm, and it's really cool to look at, and definitely a lot to learn, especially if you want to work with historical fundamental data. Right now, because we don't actually have a built-in way to work with it. But But yeah, so finally, I know I'm throwing a lot at you guys right now. Thanks for being so attentive. The last algorithm that we're going to be looking at is it was made by Richard P. He's a very active member on the Quantopian community and writes some amazing algorithms. And this one is just another one that won our fundamental algo contest. It's a bit more of a sophisticated algorithm in that it both um, uses uses fundamentals as an initial filtering method, and then later he looks at the volatility and I think price growth of each stock that the fundamental that get fundamentals returns in order to get small cap stocks with that are more on the volatile side that are also trending upwards. So let's go over it really quickly, just so you know. It's also on the community. He's kindly agreed to share it. Um, so if we are to clone this algo, just like before, we have initialize, we have before trading start, we have handle data. Initialize, he sets its commissions. Next, and before trading start, he looks at shares outstanding and market cap, and this is mainly to look at small cap stocks. So notice here that he's filtering by where the market cap is less than, I believe that is about 2 billion. And he's also looking for where free cash flow is greater than zero, and also earnings per share is greater than zero. And out of these small cap stocks, he is looking at the biggest of those small cap stocks, and he's taking the top 100. Um, Finally, he does some basic like basic appending here. So instead of taking instead of assigning his data frame into like a context data frame, he actually is just looking for the list of securities. So here, that's what he's doing. He's basically just taking the securities with fundamental data present, and he's appending it to something called context.mylist, which is a list that he's instantiated up there. And finally, he updates his universe. So he does things a little differently, which just to show you guys the flexibility of the ways that you can work with this. Um, because update universe, all you really need is a list of stocks. It doesn't necessarily have to be um, it doesn't necessarily have to be the like fundamentals columns values. It can be whatever gets you a list of securities that you want to keep in your daily universe. And next, in handle data, there's a lot of things that he does, which is to basically cancel all open orders at the beginning of day, which he does here. He creates exit orders for each stock that we're holding, along with a stop loss and a floor, and also a limit order for each of the securities as well. And these are some basic trading guards that if you want you can have in your algorithm, um, but only if you feel comfortable with it. Next, he instantiates a bunch of different variables to hold like the amount of portfolio positions that he currently has, the amount of cash that he has, and the total portfolio value at that time in his backtester over here. And he has some basic checks once again just to see if his algorithm uh, can order stocks without going to into leverage or the number of maximum holdings that he set for himself in initialize over here, context.max holdings. So that's just basic things that he set up, not really related to the logic of the algo. The actual math and the actual selection of stocks to buy happens here. So first, what he does is that he looks for where where the stock is trending up, which he does by basically taking a linear regression of the stock's prices for the past 30 days. And if if the resulting slope of that is positive, he appends that security to something called trend list, which is a list of stocks that he later. So what he does with that is that he looks at the stocks that he found in trend list, and he looks at the volatility of each of those securities by look the 30-day volatility, which if you guys aren't familiar in finance, the go-to criteria for looking at a security's volatility is standard deviation. And you can look at standard deviation very easily by using our history method, which returns a data frame, and the data frame supports a built-in dot standard deviation method. And notice that the securities that he's looking at here, the securities that he's looking for before he starts filtering out for volatility, were all based on what he got from his get fundamentals method, which started out by saying, I I only want securities uh, with a market cap of less than $2 billion, where free cash flow is greater than zero, and the basic EPS and earnings per share are greater than zero. So he started off by narrowing down his initial universe instead of doing something like set universe, dollar volume universe, which is another built-in way um, to set a random list of securities. He made that a lot more specific by using fundamental factors, and on top of that, he uses a bit of statistics by taking the linear regression of prices and filtering that down by looking at the most volatile stocks out of those that have had the biggest price momentum or positive price momentum in the past 30 days, and he uses that to create a buy list for his algorithm. So it's really a three part algo, which first uses fundamentals and then linear regression and then standard deviation to filter for smart market cap for small cap stocks, and then moving trend a price that's moving upwards, and finally the stocks with the biggest volatility. So it's like more on the sophisticated side, but it's a very good example of what a more advanced like Quantopian user or quant algo writer would be doing. And all of these algorithms are good in their own way. None are better than the other. Um, and it's really up to your discretion to figure out which one fits your strategy the most. So yeah, we just went over, and that's kind of it for this algo. And finally, he determines the order size and places orders for the most volatile stocks. So that is kind of it for the this webinar in terms of the content. We just covered Naoki's basic core fundamental algo, and then Richard's more sophisticated three-part statistics and a fundamental combination, and finally, our Quantopian Pirotrovsky score implementation, where we look at different fundamental factors over a historical data set. Um, and we also show you how to create your own kind of built-in history method that we provide for pricing data here in Quantopian. And that kind of covers it for the content side of this algo. So we have about 8 minutes left where we can go over questions now. So if you guys have any questions, if you guys have anything that you're confused about, start answering in here. Um, and uh, and I can go over that in here, or we can, do some, or you can post it in the thread, in the community thread that I'm going to be posting shortly after this algo. So if you have any questions, please start posting it in this question section and I can start going over them. So we have about 7 more minutes, so feel free to start asking. So Zipline, so Jing Cheng just asked, I cannot use Zipline in Python. Zipline is our open source backtester. We can be more specific about which problems you're running into, and I can send you the link for the Google group that actually answers technical questions. So feel free to email me after this webinar. And by the way, my email is slee@quantopian.com. So feel free to email me after that. Yeah, so I can definitely send you the link for the Google group. And so you can ask a lot of your Zipline related questions there. Paul Perry asked, do you plan to integrate with GitHub in the future? Uh, Maybe. I can't really give you a solid answer on that. We've had some questions on that, but definitely a good question. We're not sure yet. Jing Cheng asked, thanks, where can I get the tutorial documentation? I'm going to be posting up all of this, including the video, on a community post about an hour from this webinar. And so be looking for that on the Quantopian community page. Yep, no problem. So we have about 5 minutes left. If anyone has any other questions, I'm going to leave it open. But until then, there's actually a question box in the GoToWebinar control panel. So you guys can ask it there too as well. Jing Cheng asked, I learned that Zipline is not fully developed. Yeah, we're still improving it every day. And so these are questions that are better suited for the Google group. So I'll give you the link so you can ask it there. Okay, I mean, it looks like we're not getting that many questions, so we're actually just going to I'm gonna leave it open for another minute, but ask now, or else we'll just call it a day. So okay, Jing Cheng just asked, I think Quantopian will save the algo. Will that be a privacy issue? No, we actually take your your security and privacy very seriously. So that means that any algorithm that you create is yours. We never look at it unless you need help debugging it. It's entirely yours. We don't claim ownership, and we have like a lot of a lot of security policies just to make sure that that's not an issue. Okay, guys, thanks so much for coming to this webinar. Just to reiterate, we covered fundamentals. Thank you so much for staying. I know it was a lot of information. We also have the Quantopian QuantCon, which is coming up in March. So definitely, if you're in New York City area, check that out. We have a lot of amazing speakers, and you can meet a few of us in the Quantopian team there yourself. And also, the Quantopian Open has just opened its March submission deadline, which is March 2nd. So get your algorithms in before then. And we're looking to get fundamentals working then. But for now, you can backtest your algorithms in live trading and try to get that up and running. Yeah, so that's it now. Thank you so much for coming. That's going to be the end of this third series in the Quantopian webinar. We're gonna have like a survey sheet for feedback after this. So if you guys want to learn anything else, anything you're confused about, anything you want to know more, just write it all down, and we'll